and gentlemen, I am the Mathemacoder, and I'm here to show you exactly everything you need to know when you get into circles. So, let's start by, drawing a circle. I am on a keyboard with a mouse, so this is my best attempt at drawing a circle. Just pretend that's a circle, alright? Now, over here, we have a point that is located so perfect that I kind of want to call it the center. This point is the center, and it's usually represented with the point O, but other tournaments or tests can represent something else, but I'm over here going to use point O. And now, reaching out from the center, we're going to sort of like beam of lights, like beam of lights. From the center, from point O, we're going to reach out a line. Not a line segment. That is exactly from the center to an edge of a circle. And this line over here, well, you guessed it. We're going to call it R for radius. This line over here is called the radius. We're just speeding through everything here, but let's see. Let's kind of slow down for a minute. We have the center. We have the radius, right? What is the distance? For example, let me draw another, no, not on the O. Let me draw another radius here. I'm going to label it R. If this is a radius and that is a radius, let's call this R1 and that's R. What is the difference between R and R1? Fill in the blanks here. You can fill in either greater than, equal to, or less than. Wait. No, I think I might have got these two wrong, but it doesn't matter. Which one is it? Is R1 greater, R greater, or they're all equal? I recommend you to pause the video now and try to figure this out on yourself. I'll give you 5 seconds to do so. Ready or not, I'm here to give the answer. Well, of course it's the same. From the center of the circle, we call it so perfect. From the center of a circle, beams of light or radiuses moving down, moving towards any point, right? From the circumference. Well, that's another vocabulary I will tell you later. This, reaching out to the outer part of the circle, is always equal. So this length is equal to this length. I'll do a little practice with that right now. Let me just draw a little circle here with my red. Let me label the center point O. That's not an O. O. Over here we have radius 1. Oh, that's a little eraser. Oh, okay, there you go. It's radius 1. And we have radius 2. May not look the same, but, my circle is wonky. So, as you can see here, this radius, I'm going to give you the length of this radius. We're going to say 5 centimeters. And I want to ask you, what is this length? It's just a little practice from exactly what we done over here, but I'm just curious, what is this length? I will give you 5 seconds to do so. Pause the video and try to figure it out. It's not going to take that long, I guarantee you. And here we go. We are here. So as you can see, we have question mark and sum. Sum. I thought I wrote sum. 5 centimeters. Let's talk off track a little. My handwriting, it already looks terrible in real life. And consider this. I am writing on a computer board with a mouse, so it can get a little wonky, so forgive me for saying some, okay? That is not what I meant. I meant 5 centimeters. If that's 5 centimeters, this is also the radius according to this little writing over here. Radius is equal to the other radius, so question mark should be 5. Right, let's erase this bit over here. All right. right. I'm going to keep principles and keep drawing on my drawing here, as you can see. Bye-bye and bye-bye. Okay, I'm going to keep the principles, or equations, R equals R1, or radius. Oh, that's not there. Radius equal to other. I'm just going to write R. Radius is equal to the other radius, Now we are going somewhere different. See this? That's a circle, my best attempt. That's 20. What is this? 3 seconds. 3, 2, 1. That's the radius. It's right here. Radius, we're label R, and now we're going to switcheroo. What is this? Oh, dang. It's getting longer. What do? It looks, if we extend from here, it looks like 2 times the radius. What do we call it? 2 times the radius? Well, imagine this. If your teacher comes out and tell you, well, draw 5 2 times the radiuses on this circle. It's going to get kind of confusing, isn't it? So we have a different name for it. We're going to call it the diameter. Just like meter with dia, D-I-A, diameter. The diameter basically equals, as you can see on my beautifully drawn, not circle diagram here, basically equals 2 times the radius. I'm going to write that out here. Actually, I should do that in a different color. Diameter equals 2 times the radius. And the diameter is super important in finding other stuff, such as a lovely concept. Well, you probably guessed it, pi, later. But we're going to cover that just a moment here, if I can get this writing perfect. All right, there we go. Diameter is 2 times the radius. As you can see, just like the radius, the diameter is also equal to whatever diameter you draw. For example, over here, that's diameter. Oh, that's not on the... Pretend it's on the center, okay? Oh, God. Diameter. It's gonna eventually look like some sort of a spider web if I draw it here, but you get the point. Let's just write it. D, we use the D as diameter. Let's just draw it on here real quick. Try not to go over all my writing. Diameter's a long word. I'm just gonna write D. Oh, God, that's too long. D is equal to 2R. That is basically just that, but, D, diameter equals 2R. So we have let's write a little symbol bank here. Symbol. We have, R equals radius. And D, equals diameter. Okay, that is probably going to be the last time I write the word diameter, because you get it. D equals diameter. D is basically saying diameter. R is radius. Just take the first letter, and boom, you're done. Now, we have the fundamentals of circles. We are going to use our purple here. And, while I draw this, you are going to guess exactly what is it. What is this? Wow! It went all around the circle. What is that? Well, I told you before, I think. So, this purple thing is going to be the circumference. Circumference. Circumference basically means all around the circle, like the perimeter. Like the perimeter of the circle, basically. For example, if we have like a rectangle, we would call the outer part the perimeter. But in circles, well, circles are special. We give them a different name, circumference. So and we use C. And we are here for our first formula right after I write the really long word circumference. Let's try to make it as pretty as possible. Circumference. Oh gosh. Alright, you get the point, okay? That's the best I can write it because the mouse is kind of really weird to draw. C is circumference, D is diameter, and R is radius. We're going to use our little beautiful little green. We're going to call it formulas. Formulas. And as you can see for formulas, we're going to have something great here. We're going to use let's use this. Circumference C equals, well, introducing our best friend pi. This little symbol, read it as the delicious dessert you eat on Thanksgiving, pi. Pi, but it's actually not spelled as pi. In real life, we spell it, the mathematical term as pi. Pi. For pi, it's simple. We're going to use our little, what is pi? Well, would you look at that? You are never going to count the end of pi. Well, I mean, I can go up to 3.14159265335899793, and that's all. You don't even need to know that much. Usually in tournaments, tests, games, questions, trivia, you can name it all. Name it all night, but I don't have all night. You know, it's always just going to be, actually I should say, almost equal to 3.14. That's all they're going to use. That's all they're going to use to, like, quiz you. For example, if they don't say it, even though just say, find this, find that at the circle. Just pretend, if they don't mention it specifically, use 3.14. But hopefully all of them are going to mention it specifically. So pi is almost equal to 3.14. And we are going to be here for our next almost like formula, but different. What is pi equal to? Before we get in what is the circumference, we're going to ask ourselves, what is pi equal to? Well, if, like, in ancient times, back in, like, ancient China, ancient Greece, ancient Egypt, whatever, if you take, like tape measure back then, I mean, they don't have a good tape measure, and they tape measure around a circle, they would get, like, a number. For example, I think it's almost the circumference of a circle is almost 6. And then they divide it by the diameter. Look out. So pi, what is pi? The circumference over diameter. There you go. Pi is circumference over diameter. How do you do this? Let's go back to our ancient times. Circumference is 6. And they also measure the radius. What is the radius? They get 2. So they did their clever calculation, 6 divided by 2. Well, I guess this mysterious number, they don't have a name for it yet. Guess this mysterious number is almost 3. And now, a little bit earlier than now, they had their more accurate tape measure. And they did all around again. And they get it's almost 6.28. And also, this is almost 2 again. No, almost 2. Exactly 2. They measured it. It's exactly 2. Whatever unit. 6.28 divided by 2. And there we go. We have our lucky number 3.14. Ancient times, they did that. Now with our quantum computers, ChatGPT, AI, whatever, you are going to get a lot more. Like I said, 3.15415926535 etc., etc. But now we calculated to more than like a million, we're eventually going to get the number I don't know when, but eventually, if this number is actually going to be calculated done, which I don't think it will to, because it's called an infinite non-repeating decimal. Repeating decimal with all digits are different. Like digits are different, repeating decimal. All right, let's get back over here. Pi is circumference over diameter. If we know pi is circumference over diameter, I believe you are all good for a little algebra tonight, okay? Move this. If we times diameter onto both sides, we're going to get pi times d. Pi times diameter equals circumference. There you have it. How do you get the circumference? When your teacher, when brainpop.com, when IXL, Khan Academy, whatever platform asks you, what is the circumference? You can say with proudly confidence, pi times diameter. But what if they don't give you the diameter? What if they give you the radius? Well, we have it right here. Diameter equals 2 times the radius. So we can just plug that in. C is also equal to pi times 2 times r, or 2 pi r. That is the most common formula you gotta remember in your brain. It's way more important than whatever games you play, Fortnite, or whatever level you are at. 2 pi r. It's going to help you in your academic career. It's going to help you all the way to college, whatever. You're going to use it, okay? You got to trust me. You're going to use it a lot. That is the first formula. There's also another formula. Look what I'm doing, and we're introducing him right now. Look at this other formula. Should probably use a different color, like blue. What are we doing? We are shading the circle in. What does that mean? When you have a little rectangle, you shade it in, and it gave you the length and the width. You are finding the, no fancy term this time, the area. When you find the area, when you find the area in a rectangle, it's length times the width, right? But in a circle, we're going to use a little wonky formula. Right here, and I'll explain to you later. Area, should I probably use white? Area equals pi r squared. Pi r squared. That is the area. We have pi, we have the radius squared. All right, let's do a little example here. Let's erase this bit. I want to keep the bottom diagram because let me draw a new one. Let me just get rid of it. Oh, wow, I guess I could do that. I never knew that. I'm just erasing here. Give it a little second. Alrighty, let's do some practice problems. Let's use our delicious looking blue here. There's a little center. We given the radius, which is 1. Let's keep it simple. Centimeters. Not some. 1 centimeters. And I want to ask you, what is the circumference? I will give you 5 seconds. Pause the video to do that. If you can do it in 5 seconds, good job. You passed. Bang, bang, bang. No matter if you're ready or not, here comes the answer. If you want to know the circumference, as you can see here, circumference equals 2 pi r. So, let's just write that exact equation. 2 pi 1. Or times 1. Where, of course, we're going to multiply the 2 and the 1 first. C, or circumference, equals 2 pi. Or 6.28. Should probably say almost equal to 6.28. If they give you to it, well, if they told you pi is centimeter squared, that's centimeter squared. I mean, no, pi, if they tell you pi is 3.14, 6.28. If they don't tell you, just write 2 pi. It's not that hard. Make your life a little easy. Keep the number itself. Pi is not a variable. You don't have to do anything fancy, quadratic, whatever with it. Pi is pi. Pi is a number. It's 3.14. I'm not going to repeat it again. All right, let's do some area. Okay, that's actually a really good circle. What'd you like at that? I mean, over here is a little off, but, just a little erase, and then there you go. I mean, let me fix this bit. I'm trying to keep this circle, at the best, that I don't have to draw one. There we go. That's a pretty darn good circle. Better than my last one. That's definitely true. This is the center, and I will give you the diameter. Let me just draw. Bop, the diameter is 4 units, whatever. And I want to ask you, what is the area? Because this is a good circle, I don't want to shade it in, but what is the area is the question. If you know the diameter is 4, and I ask you what's the area, it's simple. So first, to get the area, we need R. What is R? Diameter divided by, I heard you, 2. So let's do that right now. 4 divided by 2. Oh gosh, that's so hard. I don't know. What is it? It's 2. All right? So that's R here. Pi, so area equals pi 2 squared. I'm going to put that in parentheses. I don't know why. You don't have to, but that's where we are. Area equals pi times 4. It's approximately 12.56, but I'm just going to leave it at 4 pi units. And okay, well, there you go. You know the radius, diameter, pi, area, circumference. But what's next? What's next? We are going to build up. Might sound weird, but I'm just going to draw a little simple diagram you're going to understand. Looks like an oval. We're not going to find the area of an oval. Don't worry. We're not. Just chill, bro. Chill down, bro. Boom! What is that? We're gone 3D. I mean, no, it's on a blackboard. We're gone 3D. Oh my gosh, you can see through. It's a cylinder. You use it in science. You use it in, well, yeah, that's basically it. You have bottles, medicine. You draw it, you solve it, you play with it, you sing with it like a microphone. It's not exactly a cylinder, it's more of a sphere, but a cylinder. It's all everywhere. When you drink from your water bottle, what is it? A cylinder? Well, it's not. It's like a. Well, the bottom part. Well, it's also not. It's a cylinder. All right. How do you find the volume of a cylinder? I'm like, how? How do you do it? It's simple. You see the area. You know how to solve a volume of you know how to find the volume of this, a rectangular prism. You know how to do it. Length times width times height, or base area times height. Same thing with a cylinder, but just like a note here. I'm not gonna write any more symbols or formulas. You're gonna have to pay really close attention. I'm not gonna write anymore. Just gonna draw diagrams. Well, let's see. It's a circle here. It may look like a little oval, but it's a circle. When you tilt your water bottle, look from down up, whatever. You see a circle. It's not like an oval unless you have a weird water bottle. But so we can just kind of draw it out here. This part is the radius. And that's basically all you need to find the base area. So let's do it. Pretend I give you the height. 2. Simple. 2 units. Let's find the base. Radius is 1. Pi 1 squared, which is basically just pi. The base area, pi. You're done. But are we? We're not. We're not trying to find the area. That's old childish nonsense that we just did 5 seconds ago. Nope, we're not doing that. We are going 3D. We're building up. One step at a time, building up. So, how do we do this? We have pi as the base area. You just gotta, just like your best friend rectangular prism, you are building up. You gotta times the height. So pi times, height, pretend that's okay, let me just erase, not be lazy here. Pi times the height is the volume of a cylinder. Let's write that in the formula. I lied. I am going to write stuff. V cylinder volume of a cylinder is equal to pi, the area, r squared, that's the base area, times height. And that's basically it. That we're done with this class, basically. And before I give you practice problems, we're going to have, one at a time. I'm going to give you 5 seconds just as usual. I regret drawing all that green lines over the circle because I am going to use it. But now I messed it up because, worth it. We advanced from a 2D to 3D, but it's good. Oh, this erasing, it's taking a long time. Alright, that's good. So, let's draw a decent looking circle again, please. That's, okay. Just, you're gonna have to use your imagination in my math class here. That is a circle, sort of. Okay, we're gonna label center O. We're gonna find the area. Given 2 radiuses, 1 and 1. The 2 radius thing is just bugging you. Get it away. We're finding the area. Come on, we're gonna find the area of the. Just get rid of one of them. They're all the same. This, that. Let's do a little challenge. Let's do 6. It's not gonna be that challenging anyway. It looks like a B, but that's a 6. How do we do it? 5 seconds for you. All right. Let's go. Let's do this. Pi. What is R? Shout it out. I heard you. 6 squared. If you did your multiplication at elementary school, 36 pi. That's the area. That's it. Now we're going on to the challenges. Oh dear, he's drawing an oval. What does that mean? Oh, I drew it upside down. Oh. It's fine. Just pretend. Yeah, I'm going to challenge you even more with this. Yep, I drew an oval. That is a cylinder. Yes. We're going to take this bit. That is 2. How do we get it? Well, you can't get it. I'm going to give you the height. 5. So let's see our little formula here. What if I covered it out? That would be really funny, but I'm not going to do that. I'm kind, okay? We're going to have our little pi r, which is 2, squared times, I can't even read my own handwriting. I don't know what that is, being completely honest right now. Let's just change whatever I said before and call it a 6. Alright, I have no idea what that is, okay? If you look before, I can't because I'm recording. If you look before and I said something else, just pretend that's a 6 for now, okay? Pi r squared base area times 6. So what is it? Pi times 4 times 6 pi times 24, or 24 pi. And we're done. You survived. Let's summarize. You got radius, diameter, circumference, area, pi, cylinder, base area. I basically summarized circles. There's also cones and other weird tube shapes, but this is all the basics. I'm gonna go into more volume next time. You gotta wait. Alright? Have a good one. You got this. You are perfect like a circle. Believe it. And take care.